50 HPLC Basic Interview Questions. Question 1. What is HPLC? Answer. HPLC stands for High-Performance Liquid Chromatography, an analytical technique used to separate, identify, and quantify components in a mixture. It is commonly used in pharmaceuticals, environmental testing, and food analysis because of its precision and ability to handle complex samples. Question 2. What is the principle of HPLC? Answer. HPLC operates on the principle that different compounds will interact with the stationary phase inside the column and mobile phase solvent to varying extents, leading to their separation as they pass through the system. Compounds with a stronger affinity for the stationary phase move slower, while those favoring the mobile phase move faster. Question 3. What is the difference between normal phase and reverse phase HPLC? Answer. In normal phase HPLC, the stationary phase is polar and the mobile phase is nonpolar, making it ideal for separating polar compounds. In reverse phase HPLC, the stationary phase is nonpolar and the mobile phase is polar, which is more commonly used for separating nonpolar to moderately polar compounds. Question 4. What are the main components of an HPLC system? Answer. The main components include a solvent reservoir for mobile phase, a pump to drive the mobile phase, an injector to introduce the sample, a column for separation, a detector to identify analytes, and a data system for analysis and record keeping. These components work together to achieve effective sample separation and detection. Question 5. What is a stationary phase in HPLC? Answer. The stationary phase is the material packed inside the HPLC column, often made of silica or polymer particles, which interacts with the sample components. The interaction between the analytes and the stationary phase determines the separation efficiency based on their chemical properties. Question 6. What is the mobile phase in HPLC? Answer. The mobile phase is the liquid solvent that moves through the column, carrying the sample for separation. It can be a single solvent or a mixture and is chosen based on the chemical properties of the analytes to achieve effective separation. Question 7. What are the common detectors used in HPLC? Answer. Common detectors include UV-Vis, ultraviolet visible, PDA, photodiode array, fluorescence, refractive index, RI, and mass spectrometry detectors. Each type of detector has specific applications based on the properties of the analytes being detected. Question 8. What is the purpose of the HPLC column? Answer. The HPLC column is the site where the separation of analytes occurs based on their interactions with the stationary phase. Different column chemistries, e.g., C18, C8, allow for tailored separations depending on the analyte's properties. Question 9. What types of HPLC columns are available? Answer. HPLC columns come in various types, including reverse phase columns like C18, octadisylsilane, C8, octylsilane, ion exchange columns, size exclusion columns, and chiral columns. Each column type is suited for specific applications, depending on the analyte's characteristics and the separation requirements. Question 10. What is the role of the pump in HPLC? Answer. The pump generates a consistent flow of the mobile phase through the column at a set pressure, ensuring the separation process remains stable. This flow must be precise and reproducible to maintain accurate and consistent chromatographic results. Question 11. What is the purpose of the injector in HPLC? Answer. The injector introduces the sample into the HPLC system, typically through a sample loop, where it mixes with the mobile phase. Proper injection techniques are essential to ensure accurate sample volume and prevent system contamination. Question 12. What is gradient elution in HPLC? Answer. Gradient elution involves gradually changing the composition of the mobile phase during the separation process. This technique allows the separation of analytes with a wide range of polarities by making the mobile phase increasingly more polar or nonpolar over time. Question 13. What is isocratic elution in HPLC? Answer. Isocratic elution uses a constant mobile phase composition throughout the entire run. It is suitable for samples where all components have similar polarities and can be separated without changing the mobile phase conditions. Question 14. How do you choose a suitable mobile phase for HPLC? Answer. Choosing a mobile phase depends on the solubility of the analytes and their interactions with the stationary phase. Trial and error, along with solvent compatibility with a column, is often used to optimize the mobile phase composition for the best separation. Question 15. What is the purpose of the HPLC detector? Answer. The detector monitors the separated analytes as they elute from the column and converts their signals into data that can be quantified and interpreted. The choice of detector depends on the specific chemical properties of the analytes. Question 16. What factors affect the separation of components in HPLC? Answer. Several factors influence separation, including the choice of stationary phase, mobile phase composition, flow rate, column temperature, and sample size. Fine-tuning these parameters is crucial for optimal separation and resolution of peaks. Question 17. What is retention time in HPLC? Answer. Retention time is the time taken for an analyte to pass through the column and reach the detector. It is an important characteristic used to identify and quantify analytes in a sample. Question 18. What is peak resolution in HPLC? Answer. Peak resolution is a measure of how well two analyte peaks are separated in the chromatogram. Good resolution is necessary for accurate identification and quantification of analytes, and poor resolution can lead to overlapping peaks. Question 19. What does a baseline in an HPLC chromatogram represent? Answer. The baseline represents the detector response when no analytes are present, essentially capturing the system's noise. A stable baseline is essential for detecting small peaks and ensuring the reliability of the analysis. Question 20. What is the purpose of a guard column in HPLC? Answer. A guard column protects the main analytical column from contaminants, particulate matter, and impurities that could degrade its performance. It helps prolong the lifespan of the analytical column and maintain consistent separation quality. Question 21. What is the difference between UV-Visible and PDA detectors? Answer. A UV-Visible detector measures absorbance at a single wavelength, making it ideal for analytes with known absorbance maxima. PDA detectors, on the other hand, can capture absorbance across a range of wavelengths simultaneously, providing more comprehensive data about analytes. Question 22. What is dead time in HPLC? Answer. Dead time, or void time, is the time it takes for an unretained compound, one that doesn't interact with the stationary phase, to pass through the column. It provides a reference point for calculating retention times of other analytes. Question 23. What is column efficiency in HPLC? Answer. Column efficiency describes how well a column can separate components, typically expressed as the number of theoretical plates. Higher column efficiency results in sharper, better separated peaks. Question 24. What are theoretical plates in HPLC? Answer. Theoretical plates are a concept used to describe column efficiency in separation processes. More theoretical plates indicate a better performing column with greater separation power. Question 25. What is peak tailing in HPLC and how is it prevented? Answer. Peak tailing occurs when a peak's trailing edge is elongated, often due to interactions between analytes and the column that are too strong or uneven. Proper column maintenance, selecting an appropriate mobile phase, and adjusting pH can help prevent tailing. Question 26. What is peak fronting in HPLC? Answer. Peak fronting is the distortion of a peak where its leading edge is more extended than the rest. It usually occurs when the sample is overloaded or the analytes interact too strongly with the stationary phase. Question 27. What is meant by resolution in HPLC? Answer. Resolution refers to the degree to which two adjacent peaks in a chromatogram are separated. Higher resolution ensures clearer, distinguishable peaks, which is essential for accurate identification and quantification of analytes. Question 28. What is an internal standard in HPLC? Answer. An internal standard is a compound added to the sample in known quantities to normalize variations in sample preparation or instrument conditions. This helps improve the precision and accuracy of quantification. Question 29. What is reverse phase HPLC, and why is it widely used? Answer. Reverse phase HPLC involves a nonpolar stationary phase and a polar mobile phase, which is useful for separating a broad range of organic compounds. It is widely used because of its versatility and applicability to various types of samples. Question 30. What is HPLC gradient elution used for? Answer. Gradient elution is used to separate complex mixtures where analytes have varying polarities by gradually changing the composition of the mobile phase. This approach often improves resolution and reduces analysis time compared to isocratic elution. Question 31. How do you optimize HPLC method development? Answer. Method. Optimization involves adjusting parameters such as mobile phase composition, flow rate, temperature, and column type to achieve the best separation and peak resolution. This process may require trial and error, guided by knowledge of the sample's properties. Question 32. What is retention factor, K, in HPLC? Answer. Retention factor, K, is a dimensionless number that describes how long an analyte is retained on the column compared to the mobile phase. A higher retention factor indicates stronger interaction with the stationary phase. Question 33. How is column selectivity defined? Answer. Column selectivity refers to the ability of the column to distinguish between different analytes based on their interactions with the stationary phase. Selectivity can be influenced by the choice of stationary phase and mobile phase. Question 34. What are some common mobile phases used in reverse phase HPLC? Answer. Common mobile phases include water, methanol, and acetonitrile, often mixed with buffers like phosphate or acetate to control pH. The choice of mobile phase depends on the analytes and the desired separation. Question 35. What is the purpose of buffer in HPLC mobile phases? Answer. Buffers help maintain a stable pH in the mobile phase, which is crucial for reproducibility and preventing unwanted interactions between the analytes and stationary phase. They also improve peak shape and separation. Question 36. What is column backpressure in HPLC? Answer. Column backpressure is the resistance that the mobile phase encounters as it flows through the column. High backpressure can indicate problems like blockages or increased viscosity in the mobile phase. Question 37. What is the purpose of degassing the mobile phase in HPLC? Answer. Degassing removes dissolved gases from the mobile phase, which could otherwise form bubbles that disrupt the flow and affect detector sensitivity. Methods for degassing include vacuum filtration, sonication, or helium sparging. Question 38. How do you calculate the number of theoretical plates in HPLC? Answer. The number of theoretical plates, N, is calculated using the equation N equals 16, tr/W, caret 2, where tr is the retention time and W is the peak width at the base. More theoretical plates indicate better column efficiency. Question 39. What is system suitability in HPLC? Answer. System suitability tests are conducted before sample analysis to ensure the HPLC system is working correctly. Parameters like resolution, retention time, and detector sensitivity are checked to ensure reliable performance. Question 40. What are some common causes of high backpressure in HPLC? Answer. Common causes of high backpressure include column blockages, degraded packing material, particulate matter in the sample, or using a mobile phase with too high viscosity. Regular system maintenance and sample filtration help prevent these issues. Question 41. What is the role of column temperature in HPLC? Answer. Column temperature can affect analyte interaction with the stationary phase, influencing retention times and peak shapes. Maintaining a stable and optimal temperature improves reproducibility and separation quality. Question 42. What is the significance of peak symmetry in HPLC? Answer. Peak symmetry is important for accurate quantification and reproducibility. Symmetrical peaks indicate good column performance, while asymmetrical peaks, fronting or tailing, may suggest problems with a sample, column, or mobile phase. Question 43. How does flow rate affect HPLC separation? Answer. Flow rate influences the time analytes spend in the column and affects both retention times and resolution. Higher flow rates reduce analysis time but may compromise resolution, while lower rates improve separation but increase run time. Question 44. What are void volume and void time in HPLC? Answer. Void volume is the volume of mobile phase required to elute an unretained compound from the column, while void time is the corresponding time. These parameters are useful for system calibration and for determining the retention times of analytes. Question 45. What is carryover in HPLC and how can it be minimized? Answer. Carryover refers to residual sample left in the system after a run, which can contaminate subsequent samples. It can be minimized by properly cleaning the injector, optimizing sample preparation, and using appropriate wash steps between runs. Question 46. How do you clean an HPLC column? Answer. HPLC columns are cleaned by flushing them with strong solvents, such as methanol, acetonitrile, or isopropanol, to remove residues and contaminants. Regular cleaning helps maintain column performance and prolongs its life. Question 47. What is peak area in HPLC, and how is it used? Answer. Peak area is proportional to the amount of analyte detected and is used for quantification. By comparing the peak area to that of standards, the concentration of unknown analytes in a sample can be determined. Question 48. What is linearity in HPLC method validation? Answer. Linearity refers to the method's ability to produce results directly proportional to the analyte concentration within a given range. A linear relationship between concentration and detector response is essential for accurate quantification. Question 49. What is the significance of reproducibility in HPLC? Answer. Reproducibility ensures that the HPLC method yields consistent results across multiple analyses or over time. High reproducibility is crucial for reliable, repeatable data in both qualitative and quantitative analyses. Question 50. What is a calibration curve in HPLC? Answer. A calibration curve is created by plotting known concentrations of a standard against their corresponding detector responses, peak area or height. It is used to determine the concentration of unknown samples by comparing their response to the curve. Thank you so much for watching this video. We hope you found the content helpful and informative. If you enjoyed it and learned something new, please consider giving us a thumbs up. Your support helps us create more content like this, and we truly appreciate it. Don't forget to subscribe to PharmaTalks for more in-depth discussions and tutorials on pharmaceutical guidelines, HPLC techniques, method development, and much more. We regularly post videos that dive deep into the pharmaceutical industry, sharing the latest updates, tips, and best practices for professionals and enthusiasts alike. By subscribing, you'll stay up to date with all our new content and never miss an important topic. Also, feel free to leave any questions or suggestions for future topics in the comments below. We'd love to hear from you and continue building a community where we can all learn and grow together. Thanks again for tuning in, and we look forward to seeing you in the next video.